Hi, I'm Anthony Taylor, and this is my presentation on how software technology has evolved over time. This presentation is partially based off Appendix A1 of the Somerville textbook, which talks about the evolution of software engineering from the 1960s. First, we begin with structured programming, which entails sequential execution of programs that flow logically and allow for structured control flows such as if, while, and for loops. We also have hierarchical organization, of functions and procedures that group related logic together and avoid spaghetti code. And we have a focus on readability and modularity, which help programs be understandable and maintainable with clear structure. Then we have graphical system modeling, which allows for multiple system views with data flow diagrams, event models, and system structure charts to create different models that capture different concerns. We have the unified modeling language, which integrates different types of modeling approaches and improves cross-team communication. We also have visual support for formal design of diagrams, which serve as roadmaps that help prevent misinterpretation during development. We then have object-oriented programming, which is the idea of the creation of objects which mix data and behavior, allowing for encapsulation that bind operations to data related to the operation. This reduces errors from global variables and loose data variables. We also have classes and hierarchies, which allow for the construction of templates and inheritance of templates to create more specialized ones. The key goals of object-oriented development are modularity, reusability, extendability, and reliability. We then move on to programming environments. Programming environments allow for integrated tools such as syntax editors, debuggers, version control integration, and testing frameworks. And programming environments help to enforce best practices of object-oriented programming and structured programming. Some examples, especially Smalltalk would be an early example, but modern examples include Eclipse, IntelliJ, and Visual Studio Code. This benefits developers with faster development, easier code quality maintenance, and better team collaboration. Next, we have concurrent programming, which allows for parallel execution of tasks, allowing for large and responsive systems. We also have threads and safe data sharing from threads, which allow for synchronization that replaces ad hoc locking. Then we have application programming interfaces, which allow different programs to communicate with each other and interface. We also have the ability for APIs to allow independent development modules, libraries, and services, and are key to scalable systems where you could work on different parts of the program without having to use the same language. Overall, the evolution of the trends and interesting conclusions are that individual craftsmanship has formed into team engineering to allow more people to work on the same problem and coordinate together. We have code-centric to system-centric thinking, where coding becomes a system rather than producing an individual program. We have ad hoc communication to formalized communication with diagrams and defined systems. And we have single threading tasks to concurrent tasks, which can safely execute tasks at the same time. That's my presentation. Thank you for listening.